Recently, OpenAI, the company behind ChatGPT, managed to raise $6.6 billion from various investors, increasing its valuation to more than $157 billion. That's a lot of money coming from a company that is operating at huge losses.
Million paying subscribers and 1 million business customers who are paying to use the technology. But the company is still far from being actually profitable. It's expected to lose $5 billion this year. AI models are extremely expensive to develop.
But there are a lot of roadblocks in the path of large language models, some of them purely technical, such as hallucination and the finite amount of data stock used to train these models, whereas others have more to do with big energy constraints, related to massive electrical consumptions of the chips used to power this technology. So what does this mean in the long term? Are large language models truly the next big technological jumps, as some say? Or is it more nuanced than that? We'll find out more in this new episode. So sit back, grab some drink, and relax. While artificial intelligence has incentivized massive investments in data center infrastructures to power large language models, its impact on business remains small. The statement is confirmed by surveys conducted last summer, where in the majority of the cases in fields involving sales, marketing, supply chains, IT, and software, respondents said that generative artificial intelligence barely decreased the cost of their operation by less than 10%. And when analyzing Gen AI skill penetration now and comparing it with other areas such as cloud computing, smart devices from the first few years of their adoption, we can see that according to government data, the skill demand for AI is still very low. This trend is pretty much confirmed by Daron Acemoglu, who predicts that the total productivity impact of AI in the coming decade will be no higher than 0.66%, which roughly translates to barely 0.9% of the US GDP. If we look at web technologies as a trend, we can see that they have followed different development cycles these past few decades. From the 1990s, with the beginning of the Web 1.0 tech cycle, which saw the rise of the first web browsers such as Netscape, the returns on investment was only achieved in the early 2010s due to the slow adoption of this technology. The Web 2.0, which arrived around 2006, was mainly defined by the popularization of social media platforms and technologies such as smartphones. So a return of investment much earlier, with most companies reaching it 6 to 7 years later. But even when we analyze the current tech cycle that many people, including big tech companies, insist will come through the rise of large language models such as ChatGPT,
I think it will be able to do anything that any human can do. Possibly within the next year or two.
Even with all the hypes and marketing involved, surveys are showing that the overwhelming majority of consumers aren't yet adopting this technology on a day-to-day basis, which is problematic considering the extremely high cost of this technology. In fact, investment in large language model is so high that in the next coming years, the largest tech companies will need to generate more than $500 billion in yearly revenues in order to offset their investment cost in data centers used to power this technology. Which, on another note, I think partially explains the massive tech layoffs that have been happening recently. Energy remains by far the biggest obstacle to the growth of large language models, as the current infrastructure simply cannot keep up with this technological evolution, as barely 6 months elapsed between the release of ChatGPT 3.5, which was trained on around 300 billion tokens, and ChatGPT 4, which was trained on 13 trillion tokens, pretty much a 4,233% increase in the number of tokens used to train these models in just a couple of months.
There is a capital question of like, okay, at what point does it stop being worth it to put the capital in? But I actually think before we hit that, you're going to run into energy constraints, right? Because I don't think anyone's built a gigawatt single training cluster yet, right?
These large language models are typically powered by some very energy demanding GPUs. The most common ones are the H100 made by NVIDIA. Each can consume up to a staggering 700 watts of power. To give you an idea, that's the equivalent consumption of an average American household, when they are at 61% of their annual utilization. But that's just one GPU. In reality, to build something like GPT-4o, OpenAI and Microsoft use a cluster of more than 50,000 H100 GPUs to specially build data centers. Environmental concerns aside, alongside AI's power needs, other trends like electric vehicle charging infrastructure build-out, reshoring manufacturing such as semiconductor fabs, and potential developments such as the next generation wireless networks are already putting a lot of pressure on an already aged power grid. To better clarify what I found, in order to calculate the data center efficiency, we typically use a measure called average power effectiveness, which is evaluated by dividing the total amount of power a facility consumes with the amount of power used to run the servers. And when it comes to modern day data centers, this metric is around 1.1, meaning that 90% of the power they consume goes directly to power the servers compared to things like cooling, lighting, and other systems. So as a result, there is very little opportunities to extract more efficiency from data centers. Developing more sophisticated ways to extract more data efficiency from these GPUs might not solve the problem. As more and more of these companies race to build the most powerful large language model, they will still try to squeeze as much power from them as possible. This is known as the Jevons paradox. In order to create a large language model, one needs data. A lot of data. So much that, for instance, ChatGPT-4 was trained on 13 trillion tokens. Tokens are basically pieces of text or words that the model processes. They can be as small as a single letter, part of a word, or the whole word, depending on how the text is broken down. According to estimations, we currently have 300 trillion worth of high-quality human-generated public text, and a recent study published by Epoch AI predicts that by 2026, all of this data stock will be fully utilized, which is why the use of synthetic data and data created by large language models themselves will become more prominent. However, there are several problems associated with this choice, including biased responses and inaccuracies caused by the hallucinations. Machine-created synthetic data could cause large language model to become an echo chamber of poor outputs, which is what researchers call math autophagy disorder. This phenomenon means that when this system lacks fresh real-world data, they start to reuse their own outputs, or those created by other models, as outputs in the future, which would significantly decrease the quality and the diversity of the data. This potential degradation of large language model output quality has significant consequences in areas like software development, exacerbating the already growing problem of code churn. In programming, churn is a phenomenon that affects code changes that were either incomplete or erroneous when the author initially wrote, committed, and pushed them to the company's Git repository, which is basically a centralized virtual location where a software company stores, manages, and tracks changes to its code base. Churn represents the percentage of code that was pushed to the repository, and then later reverted, removed, or updated within a time frame of 2 weeks. The problem with coding assistants and how they are used is that many developers that use them spend more time reading code than actually writing it. But badly written code means that the code base becomes more and more difficult to maintain and update. Coding assistants, powered by large language models, have their algorithm mainly optimized to propose suggestions more likely to be accepted by the programmer, even if they are redundant or unnecessary. But code maintenance is done more efficiently when the amount of code that needs to be read is minimized. This is highlighted in a study made by GitLab recently, when they found that churned code has seen a 39% increase between 2022 and 2023. Last year, Google launched AI Overview, a new system embedded within its search engine powered by Generative AI, designed to help people save time by avoiding having to click directly on links to various websites. And various controversies emerged since the launch of this feature. For instance, when people would search on Google a way to improve their pizza cooking skills, the system, which used data coming from various websites through web scraping, including social media platforms such as Reddit, started suggesting, among other things, to use glue on cheese in order to make it stick with pizza. This phenomenon is called hallucination, but its rate changes from a subject to another. Studies on this behavior reveal that when it comes to, for example, the legal domain, when asked a question about some random court case, ChatGPT-4 has a tendency to hallucinate on average 58% of the time, whereas Llama 2, a competing large language model made by Meta, the guys behind Facebook, was found to hallucinate a staggering 88% of the time. Essentially, these technologies are developed by being fed very large quantities of data that comes in the form of internet posts from various places such as news websites or blogs, published works like books or papers, and studies covering various subjects. In order to optimize this chatbot's output, a complex mathematical algorithm called transformer is applied that helps the machine give answers that resemble human language. These answers are always inherently probabilistic in nature, in the sense that the bot predicts which words should follow the other after a lot of trainings in computer science labs, based on data that has been inserted into it, through some technique called reinforcement learning from human feedback. It basically uses pattern matching and statistical prediction based on the training data, which makes this system highly advanced text prediction engines, but they don't really have any way to understand things like us humans do, due to the lack of consciousness. When, for example, it sees the word this, it doesn't care about the individual letters. Instead, it looks at the word's meaning as a whole in relation to the other words in the sentence, represented by a special encoding, which is essentially a numeric representation. Large language models generate text in tokens, which are pieces of words or full words. This is the main reason why when you ask OpenAI or one or any other large language model to create an essay of 500 words, it always fails, because its prediction model follows a token by token pattern. Well, anyway, thank you very much for watching, and I'll catch you again next week for the next episode.